So since then, I've been very much in product land. I work for NI, which just recently got bought by Emerson. And I very much have been the past 4 years working on this product SystemLink software. However, I've tried to keep in touch and think, hey, how's what we're doing, not only in this product, but in NI, generally applicable to the modeling world. And I've been thinking for a while, it's like, man, this product we have, it seems like a digital twin, maybe a simplistic one, but it seems like we're managing digital twins. And when this conference came out, I said, wait a second, TED Tools papers, this is great. Let's see if we can make this happen. So I give a ton of credit to Cristian, Cosmin, TJ, Josh. The bottom two work with me in Austin. The top two work in Romania. We have an awesome team working on this product, and these guys are a big part of why the product is, I think, really cool. So, if I can get the slides to move forward. There we go. So there's a lot of talk about digital twins of tested items, right? So, our customers make jets. There's a lot of talk about lots of pieces of the jets, the LRUs, the engine, the jet itself, right? The DoD wants them to, the US, Air Force to have an entire digital twin of the F-15 or F-16 or one of them. And the new planes have been completely digital designed as mandated by the DoD. So this is a big deal for those customers. Cars, the automotive industry obviously is a big thing, models all their things as digital twins, ages these things. But when you look at the whole system as a whole, if we really want to talk about digital transformation, we really want to say we've done the entire process of designing, testing, and building these devices digitally. We have to talk about the test systems themselves. Now, obviously, I have a lot of, and I have a lot of interest in this because we sell test systems, hardware and software, but I think it's very important, and we've had customers ask us for this, of, hey, how your test system behaves, how the signals propagate on the cables, how the type of data we get from the test system, we want to be able to simulate that. We want to be able to model that. We want to be able to design that in to our overall designs. What do you guys want to do about it? And so, I think there's a whole aspect of, do we release models for our test systems and stuff like that nature? But when we get down to actually doing the validation tests, you have a lab, you have test systems, your parts are coming in, you're doing validation tests, you want to get data, and you want to give insight back to the designers, back to the engineers. It would be really nice if we actually kept track of this test systems themselves, not just the parts, not just the things we're actually trying to test. Because we could do a lot of stuff with that, right? We can manage the software that's on there, understand there. We could plan calibration cycles to maximize uptime. We can maximize utilization of the test hardware we have such that we don't have to go buy a ton of new test hardware and don't tell my employer I said that because they want you to buy more test hardware. You could understand where all of your physical assets are so you could comply with audit requirements and security requirements. There's a lot of things you could do if you had digital twins of your test systems, not just of the device under test or your DUTs. But we actually do ship a product that does this, and that's SystemLink. And I have to put the little T in there. If I say SystemLink software, then it's trademarked. If I just say SystemLink, I don't have to do it, but I figured I would do it once. So SystemLink is a web-based program that is the enterprise software that allows a company to manage basically digital twins of their test systems. So they're the physical boxes that are doing physical tests, right? That's just so I'm clear here. I'm talking about physical tests, not software tests. The assets that are inside of the systems, so the SNU or the power supply or the vector transceiver or whatever it is, the physical thing that's going to be probing the device that's actually being tested. And then the DUTs themselves, right? We also have a lightweight model of the DUT so that we can understand the test data we're getting back and how it relates to all these other things. So the software solves 3 traditional problems. In the paper, I want to talk about 2, so you get a bonus problem. One of them is software management. Validation allows you to have many systems and keeping the software up to date, right? The actual software that's running the test sequence, the actual tests themselves, the software that's making the measurements. There's a lot of IP that goes into that, and there can be lots of different versions. Keeping that up to date is a real pain. And so again, people were using spreadsheets, people were basically just kind of winging it. I've been in labs at semiconductor companies where, there's a piece of paper that gets printed to give to this guy, oh, I need to go install this thing, and he does that, and then he sends the thing back. It's all very manual. The second one is asset calibration, right? Your assets must be kept in cal, right? That's the phrase that the hardware folks use. It's like, if the thing you're using to actually do the measurement is out of calibrated, your measurement is trash, right? Your data is no good. You can't get any valid insight about your DUTs. Being able to schedule those calibrations, because you may have to actually send the thing back to the vendor to get it recalibrated. That could be a significant amount of downtime. Being able to schedule that downtime in a way that's, maximizes efficiency of your test systems is very important. The last one is test result analysis, right? We're doing all these tests, we're getting all this data. One of the biggest, most important things is to be able to look at all the data and get insights from it. Not just that they pass the test or not, but maybe why are all of the DUTs of a certain type failing? Oh, they all were done on this one test machine. Maybe something's wrong with that test machine. Get that insights, and we keep track of that. And I end up telling a lot of people, at my employer, there's a lot of talk now about digital threads and, providing intelligence to tests and stuff like that. I said, well, to have a digital thread, you have to have digital twins to weave, right? This gets interesting. We can start getting insight much broadly across all of our products, but we have to model all of the things we're trying to get insight about. Because that's the only way we can actually either just use machine learning or even more, modern AI techniques to actually try to get some intelligence out of that. You have to start with good models. And you have to start with actually not just golden models, but actual real digital twins that age along with the products themselves, that actually that represent a physical instance in the lab somewhere. So how do we build this thing? It's built a bunch of containers on Linux that are basically Kubernetes. Well, it's a microservice application that I think there's something like 35 different microservices that are all written in either Python.net or Elixir for the functional programming, fans out there. They talk to the actual test systems themselves, because we tell the test system, hey, update your software. We use SaltStack to do that. We use basically Mongo to store most of the information and Postgres to store the test data. And like I said, it's actually a web application built on top of Angular. We actually built our own design system on top of Angular called Nimble that is reusable to try to give all of our applications in an eye a consistent look and feel. And then lastly, we have extensibility points with both Grafana for doing dashboarding and Jupyter Notebooks for if a customer wants to add their own types of analysis and things of that nature. So I'm going to switch to the actual demo. Hopefully, am I not sharing? I have to go back to Zoom. Where we go? There we go. Where's my? I'm not sharing. I'm trying to switch windows. I think you had me. I feel really old. Having to have someone come and switch my share and all that. My God. Just kidding. It's depressing. Oh, there we go. You just had to move the thing to the other window. Okay. Now I'm going to have to do this. Okay, so this is SystemLink. Basically, this is the starting page. Anyone who logs in, this is actually running at an I, or it's actually running on AWS, but you could run this on your own Kubernetes cluster at your industry. That's what a lot of our customers do. A lot of our customers also are moving to just running it on their Azure instance or their AWS instance. We much prefer that than on-prem. So, to say, hey, what systems do I have, right? Well, you come over here, you click, obviously, on systems, and now we actually showed 9 digital, this is basically showing 9 digital twins of systems, right? There are different people's, this is just inside for our own testing, so you have people's laptops, but you also do have some test chassis, that PXIe 8840, that is a piece of NI hardware that you could run physical tests on. Looks like they're all disconnected right now for some reason, but now you see some basic, where is it, the IP address, the model number, the serial number, the workspace. You can move things in different workspace for role-based access control, basic sort of enterprise software stuff. You go into any one of these, then you actually start the details of the digital twin. And again, this is probably a much less formal version of digital twins than generally y'all talk about, but I think you could claim it's one nonetheless. So we see the actual assets that are in this thing. Here, we have battery cells you may be testing. These are actual big data acquisition boards, things of that nature.
You would be able to see all the test results that have come through this system. You would be able to see sort of what software is installed on the system. And on the assets, you know, if these were actually, like I said, this is all a test system. If these were actually real assets, you'd be able to see when that asset was calibrated, when the calibration is due, and you could schedule things of that nature. You also see, if you noticed, you also see things such as like the health of the actual test system in terms of CPU usage, temperature, disk space, and stuff like that. So you can set up, you know, alarms and watches to make sure that, oh, if it gets too hot, you know, alert me. If it gets too, if the CPUs are running too high or something like that, alert me. So then you can take action to manage the actual physical systems based off of the monitoring done in the software system. So that is a very quick demo. I won't go too much longer on that. If anyone has any questions on it, you know, please feel free to ask me later, but let me get back to the presentation. So yeah, are there any other questions?
In the paper, I do talk about some of our competitors that have similar software to how they relate. I'm not going to give them free airtime right now. You can read the paper, but no one is actually talking, even in the other competitors from the other vendors, no one is talking about this through a digital twins lens. And I think actually as we get more involved, as more of our customers, as we were seeing, are being forced to basically shift left, embrace modeling more, things of that nature, and as we're trying to bring more intelligence to it, I think we're going to have to talk about it in this lens as we go to market. So, anyway.